Hey guys, what's up? So I've added a few different things to the Twitch chat and everything. So I think you should see it pop up in the video if you guys chat or if anyone follows or anything like that. It's all experimental, so we'll see how it goes. But I refactored the code a little bit after last week's stream. I didn't change anything. Okay, yeah, see, it should be popping up, and thank you for following. Cool. And I think the chat is popping up. Can you guys see that okay? Looks like it's kind of being hidden over there by the screen. Let's see. We'll do some live editing and see if we can fix this up. So I'll just change the background color, maybe. Or here, I'll just do this real quick. This should fix it up pretty good. Okay. I'll work on this a little bit more too in my off time and make sure that it's working a little bit better. I wasn't able to test all of this, so we'll see. But anyways, hey guys, how's it going? So last week we got to the point where we had the textures being generated. We're not really doing anything with those right now, which is fine. I just want to start getting into some 3D stuff so that we can like fly around and everything. So I refactored the code just a little bit and basically moved everything into this world namespace with a play game function, which just returns an error code if anything fails, so that we'll be able to do some tracking and stuff at the end. Okay, so just quick refresher. If I press this, it should generate a giant texture, and then it just starts running. It's not actually using that texture right now, but that's fine. And it's going to tell me this because I am working on my other library, but you know, it's not really not freeing memory, so we don't have to worry about that. Okay, anyways, the first thing I'm going to do today is create a new class inside the render. Yeah, I think it's okay to put this in the render. We're going to call this the camera. So I'm just going to jump right into it. And the camera is going to be in charge of making 3D stuff. So this is going to be inside the namespace of Minecraft. And I think I'm just going to put it in a namespace camera. Or actually, probably do struct camera. And then we'll figure out a namespace if we need one. So cool thing about C++ is you can put member functions in here. I believe they just have to be public and should be good. And I'm going to make it so that all the member functions, like if I have something, it's not going to modify, or I don't know, maybe it will modify, maybe it won't. But I tend to like functions that don't modify anything inside the actual struct because that makes it a little bit clearer what's actually going on. But to accomplish this, we're going to be following Learn OpenGL because that is the best tutorial that you can find on all of this stuff. So I sort of read through this right before just to give myself a little bit of a reminder. And we basically have to start off by getting a camera position. We need a camera target and direction, but I'm not sure we need the up or the right vector because we'll just be looking at this look at function, which just takes in a couple of different things. So inside of our camera, we will need a glm vec3, and I'll need to hash include, I think it's core. There we go. So we'll need a glm vec3, and this will be our position. And then for rotation, normally I would say let's use a quaternion, but we're in luck because Minecraft doesn't have any rolling. Minecraft, you can just alter your pitch and yaw, but you don't have to worry about anything rolling, like tipping from side to side. So we don't even have to worry about quaternions. We can just use a vector 3. We could technically just use a vec2, but this will be our orientation or rotation or whatever you wanted to call that. And what is this saying? This should be position. Okay. I'm going to follow my naming conventions, so these are going to be lowercase. Okay. So we have position orientation for the camera, and I think that should be good. And then we're going to need a function that basically calculates our projection and view matrices, okay? So we're going to need a mat4 here. This is going to be our projection. And then we'll need a mat4, which is our view matrix. And these are just the basic camera stuff that you need. Projection defines how the screen should be projected or how this camera handles the projection. And then view should be how to handle the view. And then we'll have a couple functions. And I said I don't want to modify things inside the functions, but I guess that's the only way we can go with this. So we're going to have a calculate view matrix, which will basically just calculate this view matrix and get it set up properly. Maybe we don't even need to store these though. I don't know. For now, I'm going to just not even store these. And then we'll just have this return a glm vec3. We may change this in the future because it might be inefficient if we actually cache these, and this should be a mat4. So we'll see. But anyways, this will just calculate a view matrix, and it will say, what do we need for the view matrix? So we need to just use this lookat function, which should get us everything we need. So we can say view matrix equals glm lookat, and this takes in the eye, center, and up. Yeah. So the eye is going to be whatever our position is. The center is going to be where it's looking towards, I think. Let's see what he says. So we only have to specify a camera position, a target position, and a vector that represents the up vector. Okay, so center is just the target. And we can get the target from the orientation. So how do we get the target from the orientation? That's going to be the hard part. Let's see what he does a little bit further down here. So for camera pose, he just does this, and then he gets the camera front and the camera up. And then he says that the camera looks at camera pose plus camera front. Okay, so we should probably store the camera front too. So we'll have one more vector in here, and this is going to be the front. And this will allow us to just do position plus front. Okay, that makes that easier. And then for the up vector, do we store that as well? We might have to store that as well. Yeah, it looks like it's probably best to just store the up vector. Those are kind of like the two essential things that you need in the camera, I guess. And then everything else you can get calculated from these basic vectors, right? You just need the orientation, position, front, and up. And then with all that, you can get sort of the rest of the information. Technically, you need like a field of view and all that stuff too, which we will add in a little bit. But that should be good. So that should give us a view matrix, and then we can just say return that view matrix. And then for our calculate projection matrix, let's see if he goes over that too. I'm not sure if he does. He might have done that in the last tutorial. So he talks about processing input and everything. Talks about Euler angles, which is why we don't have to worry about the roll because we're using Euler angles. And then he talks about mouse input. And that's it. Okay. So I think he talks about projection in the last tutorial, which is coordinate systems. We'll take a look at that real quick too. Okay, yeah. So there we go. So he gets the view, but that's kind of different than what we're looking for. The projection. Here we go. This is what we're looking for. So we should basically just have to do this for projection, which is pretty simple. So what does this take in? This takes in the field of view, takes an aspect ratio near and far. I think we're going to leave the near and far vectors as the same as he has them. For the aspect, I'm going to do a aspect ratio of 1920 by 1080, so HD. We will probably get all this dynamically though in the future from the window. And then for the field of view, I'm just going to store that inside of the camera as an actual value. So we'll just say int field of view, which I believe that is, no, that is not an int. So we'll take that as a float because this is like an angle. Okay. So this will just take in field of view. And then I'm just going to expand this a little bit so that's easier to see what's going on. Cool. So we've got the projection, we've got the view. Now we just need to wire all that up. So if we go into our render, which is non-existent right now, if we just go into world, which is where I moved all the rendering code, I'm going to move this out of screen coordinates into world coordinates first of all. So we're going to change these to 0.5. That way this should actually be a square in the world. And then we're going to go ahead and for now just jam a camera in here somewhere. Say hash include renderer / camera. And one thing I noticed too is that I just put all this stuff inside of the header file. That's kind of stupid. So let's go ahead and create a new file inside the render. And then this is just going to be camera.cpp. The reason you want to put as much as you can into your source files instead of your header files is because it reduces compilation time. If you keep like header files just definitions, then you shouldn't have to change them as much. And if you change a source file, it doesn't trigger an entire rebuild for all the files that include this. So just a little tip, keep most of your stuff in source and you should be good. Let's just change that to that, and we'll change that to that. And we should be good. What's this say? Oh, cool, yeah. And then we can make these consts because we're not actually changing anything. So that's also good. And I'll also do what they're telling me to do here, which is just to change this to one line of code. And I guess we could technically just return this. So simplifying our code a little bit. Who knows, maybe that'll make it easier for C++ to optimize and stuff too. Okay, and then I'll do the same thing here. We'll just say return this. Okay, cool. So we have a camera. Now if we go back into world.cpp, we have included that camera and we should be able to make a version of it. So I'll go down to right before we actually do stuff and I'll say camera, and then we'll say camera.position equals glm vec3. We'll start it off at like 0, 0, -1 in the z direction. I'll say camera.front equals glm vec3 0, 0, 0. So we'll have it like looking forwards, and I guess I could just leave that like that. We'll have this kind of looking forwards. And then camera.fov, I'll set to 45 for now. So we have position, front, orientation is equal to glm vec3 0, 0, 0. Okay, so everything should be sort of zeroed out and just facing directly towards that cube, hopefully. We'll see if that actually works. And then inside of our function here, we're going to go ahead and say, do all this stuff. And before we do this, we'll say camera.calculate projection matrix. This is the projection. And then we'll say view equals camera.calculate view. So that should all be good. And then we want to upload those to the shader. So we'll say shader dot, or I think it's an end shader, upload mat4 projection. And we have to call this U projection. And what is wrong with this? Oh, we need the shader too. So this takes in shader. Okay, so we'll just say shader and then all that stuff. I might change those too later on because I'm kind of changing my coding style as I learn more things. And so this will probably be converted to like member functions and stuff since I can do that and keep it a POD. Okay, anyways though, we'll call this uView and upload that view. So we got projection and view being uploaded to the shader, which isn't going to do anything with it right now because we need to change our shader code. So if we go into here, we can see we're taking all this stuff in, and we just want to make sure that we're taking in uniform mat4 U projection, uniform mat4 U view. And for the position, we will multiply, I think it's projection view position. I might be completely wrong on that. Well, let's double check that real quickly. So inside of here, projection view model. Yep, cool. And in our case, the model is sort of embedded within this since we're going to be doing batching and stuff. We might have a different shader for entities that does this a little bit differently, but that should be good. And then inside of world.cpp, we have all of this set up. I'm trying to think if I'm missing anything. So then we draw and we should be good. Okay, so if I just were to change like the camera's orientation dot y, we'll say plus equals 0.1f times dt, which we don't even have delta time. We'll get around to that. So just plus equals 0.1f. That should be like a rotating camera. Let's see if this actually works. No, we got build errors. Okay, let's see. Oh, those are all, okay, so unresolved external symbol. And if you're reading errors in Visual Studio, they really stink. So if you just click the output window, this is much easier to read. This basically just says a linker error though. And it looks like calculate view matrix is not found, which is weird because I did have that. Reference and function play game. Camera.h. Okay, yeah, it's saying this is not implemented. Oh, it's because I did this. Yeah. I didn't completely fix all this stuff. Okay, so we should change all this up since these are member functions and not part of a namespace. And then this can just be camera colon colon like that. And I need to include camera here too. That would help. So we'll say render slash camera. Okay, there we go. And then we can do this as well. And it says it's incompatible. That's because I didn't change these to be const. And with that, I think we should be good. Yep, that's working. That's working. Cool. Okay, so if we run this again, we should get a rotating camera in 3D space. Hopefully, fingers crossed. So we see nothing right now. With any luck, it's rotating and we'll see a square floating by. But I'm doubtful because there's a lot of chances that I messed like one small thing up. Let's make it really fast just to see and make sure that I'm not like missing something. Yeah, it never does work second try. I guess technically this is going to be the second try, right? So we'll see if it works this time. Oh, it never works first try either, yeah. I guess this is the third time, right? Visual Studio have GLSL support. Not natively. I think I installed like a extension for that. You can just like go to the extensions and then they have a bunch of different things. Oh, and I forgot to turn on the mouse highlighter thing. So yeah, there you go. So you guys can actually see the mouse. Still not working though. So I'm guessing I probably just have my vertices over here set up wrong. Like this is probably just messed up. So this is going X, Y, Z. This is the position, X, Y, Z, X, Y, Z. And the orientation of my camera is we have position and then position. I have a feeling I'm probably gonna have to rotate one of these in order to see this. Okay, it only natively supports HLSL. I guess that makes sense. And the near plane is 0.1f, I think. So I think we should be good. Wait, yeah, it's in here. Yeah, near plane is 0.1 and then 100. So I put us 1 unit away, so we should be good in that case. Let's see if it works this time. Nope, still don't see anything. Oh, it could be getting cold. Yeah, you're right. So if I switch directions, if I go from 1 to 0, if we're looking at the other face, I don't think I enabled culling though, so I think we should see it no matter which direction. Since the quad is at 0. Yeah, the quad's at 0, but we have the camera at 1, so I would assume we would be good, right? Because here, I gotta open up a note. So basically what I assume is happening is we've got our quad here, and then our camera is here looking at this quad. This is at 0. This should be at 1. Yeah. That's what I feel like should be happening, but I could be completely wrong. Wait, but what did I set the quads vertices to be? So it's at 0.5 to 0 to negative 0.5. Okay. Yes, the near plane is more than 0. And I always assumed the near plane just meant like this is the near plane and then this is the far plane. So if the near plane is 0.1 and he's at like this corner is at 0.5, then we should be good. It should still be within the bounds. I believe. I don't know. I could be wrong on this. Okay. Yeah, we'll see. I think I have probably an error inside of the rotations here. It's probably something like one of these rotations is wrong. I'll try doing this negative 90. It does look weird. The weirdest part is that it's not working. I guess that's not weird though, because I wasn't really sure if it would. Okay, so the eye is at position. Center is position plus front. Wait, okay. I set front to be, oh, okay, I see what you're saying, voxel riffs. This should be -1. I think that's what you were trying to say. And I wasn't thinking of the front like that. I was thinking the front was like where it's pointing. There we go, and now we see a cube. It's not moving, but we see a cube, so that's good. Okay, yeah, thanks, voxel riffs. I misunderstood your question, but that does make sense. So this was 0, so it was like I was adding 0, so I was just looking right here, which means it doesn't do anything. So just bad numbers. Okay, so if I change this back to 0, though, we should be good. Nope, it's still rotated weird. I'm trying to think of what direction we could be looking at this at, because it's rotated in such a weird way. And it should be moving too, technically, because we're calculating this, we're changing the orientation, and then we're recalculating the projection in view, and we should be re-uploading it. If this is using, oh, this is not using the rotation at all. Okay, so that's the next part then. We actually have to use that rotation that we're getting, which I think he went over up here. Oh, I'm in the wrong one. Okay, so if we go back to camera. Yep, so he has it looking at here, and then we can calculate what the front and the up vectors are from the rotation of our guy, right? So if we have the position in the front, that's that, but we want it to be where we use the orientation to get those values. So he basically gives us a way using all of this stuff. Yep, so he says we can get a direction vector, which I believe, I'm not sure what he's using the direction vector for. I think that's just like the direction the camera is pointing in, which should give us like the appropriate front in all those vectors. Yeah, and he basically just says that we can use the direction vector like this. So if I copy that, and then we go into here, and we say GLM vec3 direction. Okay, then this should be good. And then for the yaw and the pitch, the yaw is going to be the Y value, I believe. Let me just double check that. So yeah, pitch is forward, so that is X, and yaw is Y because we're rotating around those axes. Okay, cool. So this should be orientation.x, note dot y. This one should be orientation.x. This one should be x. and this one should be Y and X. Okay, so then we use that, and we can use the direction instead of this position plus front. We'll do position plus direction, which should give us the appropriate direction, right? This should be a unit vector, so we should go 1 unit in front of us, which is good. And then we can get rid of this front vector because it's not actually necessary. That's inferred from the orientation, which is how it should be. So that's good. And I can get rid of this. And if we would have done that right the first time, then I wouldn't have had to worry about my dumb error. So lesson learned. Okay, cool. So now it's rotating pretty wildly. Let's see if we can slow that down to try and get a feel for what's actually going on. Man, I slowed it down a lot. Okay. So the camera looks like it's rotating very strangely. And I'm inclined to believe that something isn't working quite right, but I guess that could just be because of the way I set up the orientation. Let's set this to 90 and let's see if that fixes it now. Because I know I'm usually like, I have to reset the orientation because it's off by some 90-degree angle or whatever. Okay. That definitely changed things, I think, but not the way I wanted it to. Let's try the x-axis. Let's see. See, this is where my 3D naivety comes in because I'm not used to 3D stuff, only 2D. I've done experimentation with 3D stuff in the past, but just not extensively. Okay, so when we rotate over the x-axis, we don't see it at all, which means that I think the y-axis was probably the best thing. Let's try minus 90 here. And we'll see if that works. Okay. Watch, it's going to be the z-axis, which probably makes the most sense. Because if we are rolled in a certain direction, then that wouldn't look right. But we're not even using the z-axis, so yeah, that's not going to change anything. Okay, let's see what he says later on in the tutorial. So we get the Euler angles, and he only uses the pitch and the yaw. Oh no, he does get, okay, so he does get direction.z from these two. And then he sets yaw to -90. Okay, and then he's going to get this from the mouse. And then he calculates the direction. Oh, and then he normalizes it. It shouldn't be necessary because I don't think it should be necessary, but we'll see what happens when we normalize this. So we'll say GLM vec3, camera front, and then we'll just use that instead. And maybe we'll cache that so that you can use it if you want to. Print the rotation so it's easier to visualize them. That's true. Right now, the visualization should just be going... Let's see. Because I'm only changing the Y value. Yeah, so it should only be affecting this if it's affecting anything. So it should just be like Y. And what I want it to do is like sort of a spinning kind of rotating thing. And I think that's what he's doing too. So let's do that real quick because sometimes I think it's doing one thing and I'm actually completely wrong. So we'll say logger info. And we'll say orientation %F. And then we'll do X, Y, and Z. And we just need to get those from the camera. So camera dot, all that stuff. Okay, let's see what we get. Yeah, not just the screen. Okay, yeah, so it is doing what I think it would be doing, which is just cycling through the Y values, and the X and the Z are staying the same. So that's good. Let's see what the camera front is. So I'll go into here, and then we'll go camera front. And then we'll just do camera front dot X, Y, and Z. Okay, let's see what we get here. Okay, so we're getting, when we're rotated 100 degrees, camera front is minus 0.2 in the X direction. Let me draw this out. So if we have an axis, camera front is like over here, 0, and then 0.9. So 0 in the Y direction, and then 0.9 up. So it's like pointing back here, which is not right. Is it? We might be rotating like this way, if you can see that at all, instead of like this way. So we might be rotating on the wrong plane, which would make sense. And I think that might be what he's doing. I don't think he is, though. Let's see what happens when... So he's basically saying it should look like this afterwards. Yeah, this is what we want too. So I think that's right. Let's see. Let's set up the mouse, and we'll hook this up to the mouse and everything, and maybe that'll give us a little bit more information. If I just copy what he's doing, maybe it'll just work, right? So I'll go out of here, and then let's set up a mouse callback real quickly. We'll create a new file. See, I'm not sure where to put all this stuff, but yeah, I guess I'll put this in world because that kind of makes sense. So I'll create a new file in here. We'll call this input.cpp. And then inside of this one, we'll have input.h. Okay, so we've got input, and we'll put Minecraft input, and we'll basically just have the mouse functions and yeah, key functions and mouse functions will all just be part of input. Okay, so we should have like mouse X, mouse Y, and what else does he need? He gets last X and last Y, and he gets the offset. Yeah, okay, so I think this is good. We can just sort of mimic what he's doing here. So I'll have these two variables. I'm going to separate this just so that it's two different declarations. And they will just sort of be part of input, and I think I need to do something like that just so that this is like one variable and it doesn't change from file to file. Maybe I'm wrong. Yeah, we'll see what happens with that. Okay, so input. Then we'll go into here and we'll say hash include world/input Minecraft input. And then inside of here, we need our callback. So we'll just say void mouse callback. And I'm just going to copy the definition from his thing. So we'll grab this and paste it into there. And it looks like we need GLFW, so I think I have that in core. Yep, that looks good. Cool. So we've got our mouse callback, and then we'll go ahead and implement this too right in here. And then what we can say is input mouse X equals expose. And I guess we don't need to clarify that this is inside of input since we're already in there. And we'll just change all that. So we've got all that, and we want to keep track of last X and last X pose just so that we can get X offset and Y offset, which is basically like a delta X and delta Y. That's what I'm guessing. So what we'll do is we'll go into here and say xturn int delta X delta Y. And I guess these should be mouse because we're going to have key stuff in here too. Okay, so delta mouse X, delta mouse Y, which is like a drag position, I guess. And then inside of here, we'll just say static int last X and last Y. And these should be member variables because they're sort of member variables. But we get all that, and then I'm just going to go ahead and copy all of this stuff. And then we'll modify it as we need to. So we do all this. So he says if first mouse last X equals X pose, last Y equals Y pose, first mouse equals false. Yeah, so I'm not sure why he does that. Well, I guess I am. Okay, so it kind of makes sense. This is probably a good idea too. This is one of the problems that I always have in all of my mouse listeners. This just makes it so that the dragging isn't set to like some really weird value at the beginning. So I'm going to do what he does. So we'll say first mouse equals true by default. And then if we're in the first mouse, then we just set last X to that and last Y to that. And then we can set this as false. That way the X offset or the delta mouse X will be 0 the first time. And then we can change this delta mouse Y, and then this should be that. Okay. And then we can set this, and we can set this. And he has a sensitivity variable. Okay, yeah, so this is all sort of different stuff that we don't want to be visible inside of the mouse listener. Cool. So this should just get called every time we have a callback, and then we can sort of query all this stuff, and we should be good. So if we go back into world, where I have everything right now, we'll go ahead and say, set up a mouse listener somewhere. So right after we make the context current, we'll say glfw set mouse listener, or mouse button callback, not mouse button, but mouse move. Let's see. Got mouse button. I'm not sure which one it is. Okay, let's see what's in here. Okay, so he's setting the scroll callback. That's not what we want. We want the mouse callback, yeah. Is there equivalent to logger info in Java? Yeah, tree is right. I just sort of coded that class, and so I just like go to the native Windows functions to get like the colors and stuff. Java probably has something similar that you can use. I'm just not sure how you would do it. So, okay, let's see what glfw mouse callback, because I have no idea what this is. Okay, cursor position is, okay, set cursor pose callback, yeah. That always throws me off. It's like, why do they call it cursor and then in the same breath they call it a mouse? I'm like, just choose one thing, but it works. Okay, so cursor pose callback. We'll give it the window, which is our window, and then the callback, which is input mouse callback. Let's see. Let's include world/input. And this is going to be mouse callback. Okay, there we go. Cool. So we have cursor callback. We should be able to get cursor positions and everything too. So then if we go into our update function and we do something similar to what he's doing here, should be good. So we can say float mx times equals that, and then we'll say float mx equals input mouse x, float my equals input mouse Y. Yeah, I think so. Oh, this should be delta X. And this should be delta Y. And then we can just get rid of that. So multiply that, and then we say my times equals that. And then we'll say camera dot rotation or orientation dot Y plus equals mx. That was pitch, so that should have been x. Okay. And then camera dot orientation dot x or dot y plus equals my. And then he's got this little thing. We'll copy that. So yeah, I think that's the rotation. So if this is greater, that should lock it so that we can't look over directly up or something. And thank you, Essie Woods. Yeah, I was, so Stack Overflow. I had been working on that video for a while because every time I go onto there to ask a question, it seems like I just get a bunch of hate. So I wanted to make a video and I wanted to make it high quality so that if people want to see it, they don't get turned off by me just ranting. So I was like, I'm actually going to put a bunch of editing and stuff into this one. So I'm glad you guys liked it. Oh, and no problem for the answer too. Okay, so with all this in place, and we're pulling for events, so we should get mouse callbacks. Let's see if this works. We should get like a mouse controller if we don't get errors. What's this saying? Okay, yeah, so that says unresolved external symbol, so this is wrong. I'm pretty sure we can just do that and we should be fine. Nope, maybe not. And thanks, Foxel Riffs. It took me a while to find the questions and answers for that video because so many people were just like, well, because the questions get deleted, right? So if there's any questions with a bunch of people being really mean, it usually gets deleted, so you can't find it anyways. So I had to go looking through like all the newest questions and then go looking through all the questions that were closed, which showed me a ton of people closing questions that shouldn't have been closed. But okay, let's see what this says. This is saying unresolved external symbol for all of the GLFW functions, which is weird because those should be fine. I wonder where this is going wrong. Okay. So we got this. Oh, and this shouldn't be like that. That should be like that. Okay, cool. So this should be fine. I don't see what's going on there. Let's see. Let's run this one more time. Okay, wait. So it's just saying this is already defined, already defined, already defined. Okay. I gotta Google this again. I always forget. How to declare variable in a namespace. C++. Okay, yeah, so you do xturn int. Okay, and then you declare, okay, so you say xturn int inside of the header file, and then you actually define it inside of the implementation file. Okay, so change these back to xturn. And then we want to actually define all of those inside of here. So if we just copy all that and get rid of xturns that we're actually defining them, should be good. We'll just set that to 0, 0, 0, and 0. Yeah, I know, Stack Overflow. Like I said, it's a good reference. It's just not good if you actually have questions. Okay, and then what's the saying now? So Linker is still mad about GLFW, so something has got to be going wrong there. You say you were a newbie to OpenGL and asked a question on there and then got instantly downvoted. Tried to delete it, and then many people have actively participated so you can't delete it. Oh. Yeah, I agree. The first questions I ever asked on Stack Overflow were about Roblox because that was when I first started programming. And I actually got really nice responses, which is surprising because I was asking a pretty stupid question. I had no idea what client server meant, and I was having problems with like client server differences. But the user who answered me was really helpful and got my thing working. So I was like, oh, cool, this is great. And then when I started coding in C++, I had a question that was pretty in depth, and it was a problem that only occurred when you were like doing dynamically linked libraries and stuff. And so I put just sort of a description, was like, hey, has anyone ever encountered this before? If you have, can you help me out? And I got just completely roasted because I didn't put a minimum reproducible example. And so I put in the minimum reproducible example and changed it and everything. I was like, hey, can you reopen my question? Because the guy who like roasted me, he was like, he closed my question and everything. He was like, no, I'm not going to reopen it. I was like, dude, I'm not going to repost it because then you're just going to yell at me if I repost it. So I never got that question answered, and I still don't know what was wrong with that. But, you know, it's whatever. I think the question is gone now, too, because it automatically got deleted by the system or whatever. So it's all good. I'll figure it out some other time. Okay, anyways, though. Why are we getting GLFW? You can't find GLFW. Like, that's really weird because we were using it just fine before. Yeah, I know. That's what I do now. The real Kane is awesome, and he's super helpful when it comes to C++ stuff. So it seems like it just doesn't like our set cursor pose callback. Let's see if we do this again. Nope. Yeah, something weird happened. I'm going to rebuild, and let's see if we fix this by rebuilding. So let's rebuild this real quickly. Yep, let's reload it. Okay, and now it's going to work. That's great. You got to love Visual Studio. It was working perfectly fine before, but something changed where it all of a sudden couldn't find GLFW stuff. So I'm just glad it's working now. Oh, I think I got to... There we go. Yeah, this isn't going to work, though, because I have to put that back in. So let's do that. Okay, there we go. Wait, whoa. Is this actually working? I don't know. It's not doing anything now. I can't find... Oh, wait, there we go. Okay. So if I move left, I start going left. And then if I move right, I start going right. So that's good. But it's not going right. It's like going kind of weird. Yeah, it is really cursed. Okay, let's see. So it's like I'm off kilter. I don't know. This is just weird. I think one of the... Maybe I have... I think I know what it is. I think I probably just have these switched. So let's change this to X. Whoops. Let's change this to Y. And let's change this to Y. And X and Y. Okay, let's see if that works. Wait, okay. I saw a cube up there. Don't think I can find it anymore though. Wait, okay, there we go. Nope. It's like almost there. I should probably start it off so that the camera's actually pointing at it. So let's get that first. So if we go back into world. And we've got the position and then we've got the orientation. He sets his... Which one? He sets one of these to -90 to start off with. And I think he set the yaw. So let's try that and see if we're pointing at the block. I'm not going to move the mouse. Nope. Okay. Let's change the X to -90. I could like work out the math and stuff and really try, but sometimes you just don't feel like doing math. Okay, wait. So we started looking at the cube, so that's good. And we're just moving for no reason, so that's not good. And you saw my YouTube tutorial about I'm GUI was linked on Spare's GitHub. Oh yeah, Spare. Yeah, he reached out to me and stuff, and he had let me know that he updated the IM GUI, and I was like, oh cool, I'll create a new tutorial and stuff. And he was like, can I link it? And I was like, sure. So that's pretty cool. I was like, it's cool to see YouTube video posts up there and stuff. I hope it's still accurate because I know he's been changing things. He said it should be pretty steady for a while. Did I delete the Y rotation in the loop? No, I didn't. Ah, thank you. That's probably why I keep moving. Thanks, tree. Okay. So now we're looking at it. Okay. So if I move left, I'm still moving really weird. And it keeps moving even when I stop moving the mouse. So I've probably got something wrong there. But right and left seems to work. It's just rotating. I don't know. It all feels right. Like from the way the mouse is moving and stuff. I don't know if maybe we just have the cube in a weird orientation. Okay, but for now, what we have to do is get it so that it stops moving all the time. So we say mouse X equals X pose, mouse Y equals Y pose, and then we say if we're the first mouse, last X equals the same thing. Delta mouse X equals X pose minus last X pose. Okay, and I think we just need to reset delta X at the end of the frame, sort of like I did in the game engine series. So we'll just say void end frame, and then inside of end frame we'll just say delta mouse X equals 0, delta mouse Y equals 0. I believe that's just, yeah. So then if we go back into world, and at the end of the frame, right before we pull events again, I'll say input end frame. Okay, let's see if that fixes that. Okay, yep, so we're not moving anymore, and it almost seems right. Let's see that again. Yeah, it's like almost right. I don't know. I can't tell. Something weird is going on. Let's try and work out the math and see what's actually going on. Okay, so if we go back to this tutorial, the way he explains it is Euler angles. You have 3 Euler angles, pitch, yaw, and roll. The pitch depicts how much you're looking up and down. Yep, that makes sense. And the yaw is sort of the rotation around the y-axis. Yep, we only care about the pitch and yaw values, which is fine. Okay, so then he goes over some basic trigonometry, right? Cosine x, sine y, hypotenuse equals 1. Hey, Pattonzolo, how's it going? And you really don't like the fact that I had to change 2 files, the header and the CPP, to add a function in C++. Technically, I don't have to do that. If I wanted to, I could just go input.h, void some function, and then I could say alt enter. Does that still count? I mean, technically I'm changing 2 files, but it automatically did it for me. So I don't know. I get what you're saying though. And it is kind of annoying, but you just get used to it. Okay, so if we go back here. So if we define the hypotenuse to be 1, then we know what these values are. That's true. Okay, so this gives us, okay, yep. So he's just going over some trigonometry. If we take this knowledge and we have a given yaw value, then we can use it to create a camera direction vector. Okay, so we're converting to radians. Am I using angle? Yeah, degrees here. So this is degrees, that's good. And then I believe we convert that to radians. Yes, okay, so we convert that to radians. So that's all good. This solves how we can get 3D direction vector from a yaw value, but pitch needs to be calculated as well. Let's look at the y-axis, and as if we're sitting on the xz plane, okay? So this is the pitch. From this, we can see, okay, what the yaw value should be. So he says direction y is sine of the pitch. Yeah, that all makes sense. Okay, and he's treating pitch as if it's the X value and yaw as if it's the Y value. So I'm going to copy this one more time, and then I'm going to try and get all this right. So yaw should be Y, and then X should be pitch. So let's try this again. Wait, what was that? That was pitch. So that should be X, should be Y, should be Y, and should be X. And you said, did you click the link to become famous after I ended the last stream? No, I'm not sure what that is. You'll have to expand on that a little bit more. Okay, let's see if this fixes this real quickly. Okay, so now we don't get anything, which kind of makes sense because we got to change this. The real question is why the grass quad after, yeah, 45 degrees after it's rotated. That's what I'm wondering too. And I think, yeah, I'll check what the coordinates are and stuff too. The camera's rotated. That's probably true. Yeah, I think you guys are right. Let's see. So we get the direction vector, we normalize it, and that's what we call the front. And then we say look at, oh, okay, this is the problem. The up vector. I never got the up vector. Reset. Okay, this makes a lot more sense now. So how do we get the up vector from the right and the front? Well, we just have the front. Do we have, no, yeah, we just have the front. Okay, so this is some calculus type stuff here with cross products and all that, but I guess it's technically not calculus. Okay, so if we have the front vector, which is pointing some direction in 3D space, we can cross that with just the x-axis, right? And if we do this cross x, that should give us something else. Okay, I have to do cross from right and front. Yeah, I know. That's what I'm thinking too. And that should just give me the up vector, right? Well, I have to do cross from right and front, but it's like the right vector of the direction, right? So if this is the direction and this is the right vector, that'll give me the up vector. But how do I get the right vector when I just have the front vector? This is a good Google question. Okay. How to get up vector from direction vector. Yeah, see, these people know what they're doing more than me. At the first frame from world up and camera front. Yeah, I always get confused, and unless I'm like actually focusing on the math a lot, I usually don't get it right. So if I have these vectors, okay, what's this guy saying? Come on. Just looking for, if you want to be, as you said, upish, you can find the vector forward cross 0, 1, 0. Oh yeah, because technically if the y value is our forward vector, then if we cross it with the forward, that should give us, like, translate it to different coordinates. Cross forward. Wait, no, that doesn't make sense. Never mind. Okay, let's go to a different form. Let's see if... Okay, there we go. Game development exchange. These guys are usually pretty good. Okay, keep in mind you need some other piece of information. A direction by itself has no intrinsic up. You typically have some kind of global up. Yep, that's true. From this, you can use cross products to calculate the right vector or the left vector, depending on the handedness, the cross product of your normalized forward view. Okay, the cross product of your normalized forward vector and the normalized world up vector gives you the right vector. From there, you can calculate the view's up vector. Okay, so we have our global up vector, which is pointing 0, 1, 0. So then we can go vec3 local right equals camera front crossed, how do you do cross product and GLM? I think it's just the multiplication, but I'm not sure. Cross product and GLM. You were right. Yes, thank you. Okay, no, we can just say cross. Okay, that's what I thought. Okay, cool. So if we say glm cross, okay, there we go. So we do front cross with global up, which is just 0, 1, 0. That should give us local right, and then to get local up, we should be able to cross local right, or no, we should be doing camera front with local right, I believe. Double check that. So the cross product of normalized forward vector and world up gives you the right vector. Yep. The up vector is the cross product of the right vector and the forward vector. I'm not sure. I think there is no associativity with cross product. So like the order you does this matters. Okay, so let's try this out. And then instead of using up, we'll use local up, and we'll move up from here. Okay. Yeah, and I was never setting up in the first place, which is why it was always calculated wrong. So that makes sense. Still not seeing anything. Let's see. I think it's because of this, if anything, maybe. Oh, okay. I saw something. Yep, I can't get over to that. Let's just take this out completely. And let's see if this works. Okay, there we go. And it's rotated the right way. Awesome. And would you look at that? So my right to left is wrong. And my up and down is wrong. Okay, cool. But this is working now. So this is right. I just have to switch left and right and up and down because, yeah, they're going the wrong directions. Cool. So if we go and we say x plus equals my, yeah, let's see if that fixes everything. See, this is what's nice about having a bunch of extra people here to help me out when I can't figure something out. Okay, cool. So I can't tell if this feels right or wrong. Yeah, I think this is right. Yeah, this definitely feels right. Cool. I just need to lock the mouse. And then we'll bind escape to exit out of the game. So where do I get key callback? Yeah, looks right to me too. It's always weird because different 3D programs set up controls differently. So like whenever I use Blender, it always throws me off because it's a little bit different. So yeah. Okay, key callback. Window, and then we'll use input key callback. And then we'll go into input and say glfw key callback. Right there. Key input. And this is what we need. So go ahead and say void key callback. And I've just got double parentheses there. So we'll remove those. That should be good. And then I'll go ahead and implement that. And we need an array to hold our key values. So we'll just say xturn bool. Yeah, standardize the 3D FreeCam controls. I agree. If they did that, it'd be a lot easier to switch from 3D programs to different 3D programs. But so we have bool, and we'll say this is the key pressed. And I'm going to do this way. Key last. Yeah, okay. So somebody mentioned this in one of my comments. You can use glfw key last, which just gives you the very like the highest number for all the keys. So that's pretty cool. Okay. And then if I go into here, we can say, We just need to redeclare this. Yeah, we just need to redeclare this. So I'll just copy that, put it into here. And it is nice, yeah. And I don't think I need to do anything. I'm not sure if this gets 0 initialized, but if it doesn't, we can fix that later. For now, though, we'll just say keys, key pressed, key equals action equals GLFW action. Nope, GLFW press. There we go. Okay, so if it's pressed, then the key is pressed. If it's not, then the key is not. All right, I think that's good. So we've got this set up to the key callback. And we should be able to go into here now. And I just want to set it up so that if input key pressed, well, I guess we'll call this is key pressed. And then I'll go ahead and implement that in a minute. So we'll say GLFW key escape. Then we'll just say is running equals false. And then we'll go up here. And we'll just say bool is running equals true. And then we'll say while that and is running. Okay, so if we hit escape, we should not have anything happen. Well, no, we should have the game quit. Okay, so then if I just go bool is key pressed, takes in a key. And I'll just do that. Return key pressed key. And then we'll just make an assertion that key is greater than 0 and key is less than GLFW last key. Invalid key. Okay. Let's see if that works. If that works, then we can lock the mouse and then we should be able to actually use this kind of like a controller. That works. Cool. First time. So that's at least one thing that worked first time this stream. You know, just thought Minecraft is a giant 3D cellular automata game. I guess that is true. And that's something I've been thinking a lot about too, because once we get to entities like crops and all that stuff, redstone, I was trying to think of what the optimal way to update all the blocks around it would be. Ideally, what I want to happen is like you just scan through a chunk and then you update all the blocks. And you just have to scan through the chunk once. But with things like redstone, I feel like that might throw a curve, because all of a sudden, if you have a redstone powered block, then you have to go back and like track the redstone and see which direction it goes to update all those blocks properly. So yeah, I don't know. We'll have to think about that once we get to that point. For now though, I just need to get a first person controller working. Okay, so we have the mouse and everything. We have all this stuff. What do we want to do? We want to say if input is key pressed, GLFW key W, camera dot position dot plus equals camera dot forward. Okay, so we are gonna need the forward vector times, I'll do like 0.5, 0.2. That sounds right. Yeah, let's leave that future for us. I agree. And then I'll be mad at myself for not thinking more about it. But hey, having a week between streams is kind of good because it gives me a lot of time to think before I get to the next stream about how I might approach solving whatever problem we have. Okay, anyways, though, we need to get the forward vector into here. So say glm vec3 forward. And then inside of here, this is the camera front, which is also the forward vector. So I'm just going to call this forward instead. And then we'll change this, and we'll change that. And this is going to say I can't do this because this is a const function. So we're going to have to make this non-const, which makes me sad, but it had to be done. Okay, so we've got all that. That's good. So then if we press W, we can go forwards. That's good. If we press GLFW key A, we can press, or we can go camera.forward times 0.2 backwards. And I guess we'll call this player speed. This is a float, not an integer. Player speed equals 0.2f. And we'll just change that. Cool. Do I plan on adding multiplayer support to Jade Engine? Not to Jade Engine, just because I think once we get Mario up and running and stuff, that'll be good. And I've never done multiplayer before too, so it'd be kind of hard for me to do tutorials on that until I learn it, which I kind of want to experiment with learning it in this series, so we'll see about that. But I also want to start doing like one-off series and stuff. So instead of just adding these to Jade Engine, I want to do like a mini series on multiplayer. How do you code multiplayer and stuff? Or a mini series on mouse picking, or you know, auto resizing your game. So like making it have an aspect ratio that's appropriate or something like that. So yeah, I think that's the direction I'm going to go more towards in the future, because having a giant game engine series is really hard. Like the physics one, yeah. Kind of like the physics one, except actually finishing those series, unlike the physics one. So, is key pressed? GLFW key A. This should be S. Yeah, with the physics series, I really wanted to finish it, but I started trying to redo it, or like I started coding out the next portion for the next tutorial, and I was going based off box 2D. And I was just like, I have no idea what any of this stuff is doing. There's no way I can teach a tutorial on it if I don't understand the math. And I went through his code and stuff and explained it, but that doesn't mean I really understand what's going on still. So unfortunately, I think I took on a little bit more than I could actually do with that series. Okay, so if we press key A, we want to go right, which... Okay, we can get the right vector just by crossing. We did this just a second ago. Just by crossing forward with the up. So I'm going to do that. Instead of storing that, we might want to store it in the camera later on, but for now, we'll just do this. And this could be camera.forward. And we'll say local right times player speed. Else if is key pressed, GLFW key D. Then we'll do the same thing. And I guess this should be minus equals. Where did I learn the 2D physics from though? I didn't learn it from anywhere. I mean, I did learn it from some places. I was sort of just making things up as I went along. And I think the main book that helped me is this guy. I'm probably spelling his name so wrong, but yeah. So it's probably mainly from this guy. He actually codes a physics engine. It's 3D and it works. And so I was just trying to translate those concepts. Don't show this. I was trying to translate those concepts into 2D, right? So the problem with 3D and 2D is in 3D, you have cross products, which makes sense because if you cross this with this, it gives you this. But then in 2D, you have just two dimensions. And so crossing doesn't really make sense, right? There is no such thing as a cross product. What happens if you cross these two vectors? It gives you a third dimension. So you sort of have to change the angular physics and stuff to account for this, which is the part that I couldn't really do. And you start making a game with Jade and plan on adding multiplayer. That'd be cool. First part's before adding multiplayer. Will you get issues adding multiplayer support at a later stage? Multiplayer is really tricky because like if you add multiplayer support, it's still not like you can just build a game in an engine and it just works. You still have to do extra stuff within the engine to make it work. If you've ever programmed Roblox, which I know is kind of cringy, but if you've ever programmed with it, they make a very clear distinction between the client and the server, and you have to update the client-server relationship yourself. Like you can't just build a game and then it automatically works on multiplayer, because you have to figure out what data you need to send back and forth and all that stuff. Unless you could make like a completely deterministic game engine, which is very hard. Then you could just have like all your game engine run on the server, and then you could just pass input back and forth and replicate that on the client, and it should play out the same for everyone. So Determinism is really cool, but it's super hard to get right. So, yeah. We should have a player controller here, though. If we go... Okay, yep. So I can move around the world now. Look at that. We are in 3D space flying around stuff. Very cool. I think it'd be even cooler if we made that an actual cube. And Roblox is like a whole nother world. And yeah, game studios are making those games. It's insane. But I really, really like their engine just because of the simplicity. And the way they set up the client-server relationship is super easy to understand. So if you want to look at anything for like a good example, I would say look at their APIs because they did a really good job on how that works. But yes, hype. We've got a player controller up. That's pretty cool. Let me lock the mouse real quickly. Yeah, Lua is simple too. I like Python better though. So let's see. GLFW lock mouse. Let's see what they say. It always takes you back to the input guide. Like the input guide is your best friend when it comes to stuff. Okay, cursor mode. Cursor disabled. Nope. Cursor hidden. Well, maybe this is what we want. If you wish to implement mouse motion-based camera controls, set the cursor mode to disabled. This will hide the cursor and lock it. That is what I want. So just copy that. And right up here when I'm doing all my GLFW stuff, we'll do that. Cool. Why do you hate Python, Tree? It's the best. I don't know. I really like Python, and my mouse highlighter is being very weird now that it's locked because it's just locking to the center of the screen. But I don't know. I think it's because I learned Python first that I liked it. I looked at like Ruby, and I think Ruby is similar to Lua, and I didn't like Ruby either. I was just like, I'm used to Python, and I like Python better. So Lua isn't bad though, and it's good, you know. There aren't even curly braces. Yeah. That's true. Okay, so we got player controller. I want a 3D cube on the screen though. That would be even cooler. So let's go ahead and let's add a couple more triangles. I'm gonna do this manually for now. Should I do this manually, or should we create some sort of cube generator thingy and then we'll expand upon that? Yeah, let's do that. So we'll go into here. We'll have a chunk.h file. And this is going to be our chunk generation. And then we'll go into here. And we should put a chunk.cpp. It's not going to do much right now, but in the future it'll work. Actually, okay, yeah, it's not going to do much right now. So we'll say namespace Minecraft, namespace chunk, or actually I'm going to make this a struct. Okay, so what does a struct or a chunk need? It just needs an array full of integers. And how many IDs can we get with a 2 to the 16th? If I do 2, where's the power variable here? 2 to the 16? 65,000 blocks. Okay. So if I do 2 to the 8th, that's only like 256. But 2 to the 16th, yeah, bytes. What? A byte is 4. Yeah, that's 32 bits, right? So I want to go with 16 bits just because it'll save some space. And once we get around to implementing multiplayer, we'll want this to be as small as possible. I think 65,000 blocks is more than enough. Like we could never need more than that. So I think I'm going to go with an int 16 pointer, and this will be our chunk data. Okay, and we need to go hash include. I think this is this. Yeah, but we're just going to do core.h, which should do the same thing. Okay. Wait, isn't int 16 bytes? No, int isn't 16 bytes. Int is 4 bytes. Yeah, okay, 4 bytes. I'm getting confused now. Yeah, 32 bits. See, this is why I use this, because this just makes so much more sense. 16 bits. Makes a lot more sense to me than 2 bytes, but a byte is 8 bits, right? Yeah. Okay, bits, that's what you meant. 4 bits, though, too small. Okay, so we're gonna stick with 16 bits. We may shrink it or grow it in the future if we want. But what I want to do is we basically have like a lookup table, okay? So an ID is just a block ID. That's all we need to store. And then we can store like information on how to build the block. So like the model, the textures, all that stuff in just one giant map with all the block IDs. So ideally we would have something like block map. And I don't even know if I would make this a struct because this isn't really a structure. It's just a thing. And we only have one of these things. So maybe I'll make this a namespace. And then inside of block map, we could say, first of all, delete that semicolon. We have like a map from an int16 to a block type. We'll get around to that later. That's too complicated for now. For now, we're just going to focus on cubes. And we're not even going to worry about texture data. All that stuff will be stored in here, though, once we get around to that. Okay. So I like this, but what we need is a namespace, or actually, we could just have void generate. So this generate function should generate a chunk. Maybe. We'll see. We need a way to build the chunk too. Yeah, so I'm just trying to think, because basically we don't want to store all the vertices and everything in here, because that would be a lot of information. We just need to store the IDs. And then on each of the clients or each of the people's computers, they can build the chunk themselves. So I want to separate these concerns. Yeah. And see you, SE Woods. Thanks for coming. And see you, Voxel Riffs, too. I'm sorry your electricity died, but thanks for coming to this. So this generate function will just populate these IDs. And then inside of the world function, we're going to have like a void build chunk method, which takes in a chunk. And this is going to be a const reference. See you, Patanzola. Entry. Thanks for coming. Okay, so we're going to go ahead and include world/chunk.h. Okay, so we've got this build chunk method, which should build it. And I guess technically we would want to render it and everything too. So, oh wait, you're staying tree. Okay, thanks. So, oh, saying bye. Oh, okay. Oh, okay, cool. Thanks, Patanzola. Cool. So you guys are still here. Okay, so we're gonna have like local chunk data, where I guess, yeah, this is kind of hard. Yeah, I'm gonna call this local chunk. And this is going to be like server chunk. Okay. I don't know. This is kind of tough. So this is going to be a chunk, and then this is going to be a local chunk, and the local chunk is going to be where all like the vertices and stuff are actually stored. And I think we're just using integers for that. Let's see. If I look at world. Oh, you're staying too, Voxel Riffs? Okay. I saw your electricity die and I thought you were having to go, but that is cool. Okay, so we're storing these as all floats. Let's make a vertex just so that I can think about this a little bit easier. Okay, so we're going to have a vertex, which is just a vertex. This is going to consist of a position, which is just going to be, what, 4 floats. So GLM vec4, vec3, position, UVs, all that good stuff. And then for now, actually, no, we're not even going to include color. I don't care about color. So, oh, okay, you're going to stay as long as you can. That's cool. Thank you. So I can remove all this stuff too in the future. So we just have this and this for now, which is good. That's all I need to think about right now. And then what we need is like a way to generate a bunch of vertices. So I guess this should return like a vertex array. And we'll move this down. Yeah, so we can generate a vertex array. And that's what we'll do for now. Okay. This is what we'll go with. This is probably going to change in the future. I just need to start coding. Okay, so let's include world/chunk. We'll say namespace Minecraft, namespace chunk. Nope, not namespace chunk. We got a function in there, so we'll just say vertex star chunk generate. Okay, so this will basically go and say, for now, we want to generate, so we'll say this chunk data equals chunk data data. I don't know. This is going to be equal to int16 star alloc memory size of int16 times, we'll say const int chunk width, const int chunk height. This is equal to 16, 256, const int chunk length equals 16. Okay, so this is going to be that times chunk width times chunk height times chunk length. That should give us all the memory we need. And for now, we're just going to say memory memset or 0 memory. I guess that works because that's what I want to do. Chunk data size of int16 times chunk width, chunk height, and chunk length. Okay. You should probably make these const express. Yeah, I guess I could like make this a const expression, chunk area or something. Do people on YouTube know that you are stream every Saturday? I put one announcement a while ago. I figured that I would get this to a good point. So like after this stream, I think it's gonna be at a pretty good point. And then make a little like formal announcement video so that people on YouTube can come watch if they want to. But I'm not really, I haven't used const expression too much to tree. I probably could do that for this, but I think it's fine. I think the compiler will figure it out, hopefully. Okay. So we got the chunk data, we zero that memory, so everything should be 0. That means we have 0 IDs, which is good. And then what I'm going to do is say return, well, actually, I guess we should say vertex star vertex data. Yeah, const expression is compile time. Yep, kind of like a macro. That's what I thought. So if I did like const express, so if I did like chunk area equals, yeah, see, this is where I'm like, I have no idea what I would do with this. Would I just do that and then say like, I don't know, because I could just make a const expression for this too. Like I could just say const int chunk area and then just do the multiplication there. So you basically first use const expression and then const and then macro. Okay, that's what he told you. Yeah, he's probably right about that too. I'll have to look into const expression and see how I can use those in the future. For now, I think this should be fine. Like, because it should get optimized away since those are all const anyways. So hopefully. But so we vertex data. We want to say alloc the memory for vertex times, and that should just be vertex. How many vertices do we need? We don't actually know that up front, but I'll allocate enough for the entire chunk. So we'll do that times, and then the vertices per cube. Oh, yeah. I wanted these to be allocated on the heap just because this is going to be quite a lot of memory, and I don't want to be cluttering up the stack with all this memory. So that makes sense. I see what you're trying to say now. Yep. Okay, so for now, what we're going to say is each cube can have 8 vertices, right? 1, 2, 3, 4, 5, 6, yeah, 8 vertices. We're gonna have to figure something else out for that too, like a max vertex limit so that other objects can use more vertices or whatever. But we'll do this for now. And then we'll just say for int I equals 0 until I is less than chunk width. I guess this should be x. Okay, so x equals 0 until x is less than chunk width. X plus plus. For int y equals 0 until y is less than chunk height. Y plus plus. For int z equals 0 until z is less than chunk length. Z plus plus. Okay, and now we're inside of this. We want to basically calculate vertex data for each cube. For now, we're just gonna have this centered at the origin. So, gotta pull this out real quickly. If we got this point here, we want to go back, right, and up to get the top corner. And then from there, we can get bottom corner, front. If this was to scale, this would actually look right. But yeah, and then we can just sort of build the cube. So we're gonna be doing like the center is where these are all. Yeah, so now we're drawing the inside of cubes. Yep. I want to generate just like one chunk. It's not going to be optimized or anything, but hopefully it'll work. So this is like the center, whatever XYZ is. And then if we want to say float, or actually I guess we could just say vertex vert dot position equals, okay, so we need 4 vertices actually. So we can say vertex vert, and we need 8. So verts 0 dot position equals glm vec3, and this is going to be, so x for the top right is going to be this x plus 0.5f. Y is going to be this y plus 0.5f. Z is going to be z plus 0.5f. Okay, so that should be good. Yep, I like that. And then we'll just cast these all to float. Okay, so we got vert 0, and then we can say verts 1 dot position equals verts 0. I'm going to number these out just so that I know what I'm doing. So we got cube. Very badly drawn. I should be getting the rest of the equipment I need to set up my drawing tablet, so hopefully this will work better now. Okay, so this is going to be 0. We're going to make this 1, 2, 3, and then this is going to be 4, 5, 6, 7. Okay, so from 0 to 1, we're just going forwards in Z, right? Because this is, or no, this is X. We made this Y, and we made this Z. Okay, so that should just be forwards in the X direction. So vert 0 plus glm vec3 1 0 0 verts 2 dot position equals 1 plus, or 1 minus, so okay, so we would do verts 1 minus 0 0 1. What is wrong with this one? Oh, this should be position. And this should be position. That makes more sense. Cool. Verts 3 equals verts 0 dot position minus 0 1, I believe. 0 1 2 3. Yep, that's right. 4 is going to be dot position equals verts 0 dot position minus 0 1 0. Verts 5 equals verts, let's see, we can just sort of 1 down. 1 dot position minus same thing. And I can just sort of copy that, and then we'll do 6 and 7. 6 is 2 brought down, and 7 is 3 brought down. So 2, 3. Okay, so that should give us a cube, hopefully. And then we want to set the UVs to, I'm just going to set the UVs to whatever we have in here for now, which is all this stuff. 1, 2, 3, 4, 5, 6. Okay, we have 6 per square. So did I do this right? I think I did this right. We're going to be using, what's the second one? The element buffer too. Okay, so we shouldn't have to redo this multiple times. But yeah, for the UVs, what we're going to do is we're basically just going to kind of make them weird. Okay, so UVs for vert 0. That should just be a GLM vec2. So I don't know what I was thinking when I said vec3. And that should just be UV. Okay. So UV is going to be GLM vec2 0, 0. Let's see. So this is going to be right here. So we'll make that the top, I guess. Yeah. That sounds good. So 0, 1, 2. So that would be top right, bottom left. So top right would be 1, 1. This would be top right, bottom right. Let's see, what would that be? If I can think, 0, 1, or no, 1, 0. Okay, and then verts 2, we're going to say 0, 0. And then verts 3 is going to be 0, 1. Okay. And then for 4, 5, 6, 7, we're going to do exactly the same thing. This probably won't work out very well for the sides of the cubes, right? Because it's going to look really weird on these sides, but we'll figure that out when we get around to it. Okay, so we have UVs and we have positions that should be calculated for every single cube. With any luck, that'll be right. And I need an element buffer too. So let's make one more wrapper. This is going to be like a struct. Let's call this chunk render data. Okay, and then this will be a list of vertex. So that'll be the vertices. And then we'll have a list of elements. That way we can just sort of upload these to the GPU pretty easily, hopefully. So we also need to generate the elements here, which I'm going to say int 32 star elements. Yeah, the entities and stuff will actually be a little bit easier because the way I plan on doing this, and this will be simplified in the future too, I plan on getting this so that we can use model data and just like have a Blender file and then import the Blender file, and we won't have to worry about manually setting all this stuff up. So that's hopefully how it'll work in the future. We'll see if that actually works out the way I think it will. So this is going to be alloc memory, size of int 32 times chunk width, chunk height, chunk length. Okay, and we have 8 vertices per cube. How many triangles do we have? We've got 1, 2, 3, 4, 5, 6 per face. We have 1, 2, 3, 4, 5, 6 faces. So we have 36 elements per cube is what I'm thinking. Yeah. Okay, so if we've got 36 per cube, we can just sort of do our 0, 1, 2. What should it be? 0, 1, 2. This could be one triangle. And then we're going clockwise. So 0, 2, 3. 0, 1, 2, and 0, 2, 3 should be how the elements go. So we can just say elements for this specific vertex, which is XYZ. Oh, and this is, yeah, this is the next part I got to do too. So then once I get these 8 vertices, I have to figure out where to put them in the global array. So we'll go ahead and we'll say vertex data x plus, we'll do x times chunk width plus y times chunk height. No, this isn't right. Is this? Maybe it is. Plus z times chunk length. Nope, this is wrong. Okay, so we need to do y, because I think y, or let's see. Going z, y, and x. I think what we want to do is, we want to Google this is what we want to do. Okay, so let's see. Expand 3D array into 1D index. Yeah, so that's x plus y times width. X plus width times y plus depth times z. That sounds good to me. So we'll just copy this guy. So x plus chunk width, and we have our z flipped from what they had. So we'll just change that, and then this should be chunk length. Okay, so vertex data that equals verts 0, and we basically just want to do 8 of these, right? Yeah, that should be good. And then we've got 8. Okay, cool. So we also need to add 8 to each of these. So we say times 8. Okay, I will be very surprised if this works first try, because I'm pretty sure all this should work in theory, but I have no idea what's going to happen. So we'll do that until we get to 8, and then we'll just say equals verts I and plus I. Okay, I think that should be good. And then for the elements, what we say we want to do 0, 1, 2, 0, 2, 3. So for int I equals 0 until I is less than 36, because we have 36 per face, we'll say elements x plus chunk width times z plus chunk length times y times 36 plus I equals 0. Okay, so we want to do this sort of in chunks per face. So I guess we should do for 6 faces. This is going to go wrong. Okay. So this can be plus 0, plus 1, plus 2. We want to do 0, 1, 2. And then we want to do 3, 4, 5. And this is going to be 0, 2, 3. Okay. So with all this in place, this is not going to be 36 since we're doing this in 6 faces at a time. What I'm going to do is I'm going to say this is going to be int element index 0 equals that. Okay, so that's element index 0, and then we can do this 6 times. Actually, I guess I could just call this element index. And then we could just do this as element index plus plus, and we're going to make this not const. And then same thing here. And here. And we'll do the same thing for all of these too. Okay. Yeah, I have a feeling this is going to go horribly wrong, but we'll see what happens. And instead of this returning this, we're going to say this is going to return chunk render data. And we're just going to do that. And change this up here to return chunk render data. So we have all the data we need here. So we can finally say, after we finish generating all that stuff, chunk render data return ret.elements equals elements, ret.vertices equals vertex data. Return ret. Okay. Wow, I have no idea what's going to happen when we do this. Fingers crossed it'll work, but I honestly doubt that. So inside of the world, we're going to go ahead and just generate a random chunk and see if this works. We'll say chunk dot generate. We're going to say chunk render data equals chunk dot generate. And then we basically want to upload all this to the GPU. So where we were doing this, we're going to use the chunk data instead. So instead of doing this, we're going to go up here. We've got our VAO, we've got our VBO, bind array buffer, VBO, size of vertices, but this is actually going to be chunks vertices. So we're going to say data dot vertex size bytes, and then we're going to do data dot vertices static draw. We'll change that to dynamic draw. This doesn't really have much of an effect. OpenGL just sort of does whatever with this anyways, but it's good to do that. And then we also want to do uint32 EBO, bind buffer, element buffer. No, I think I just, let's look this up real quick. Okay, OpenGL. And I think he does elements in this one. I guess I should probably look at the documentation for stuff like this, but this is just the easiest thing for me to do. Okay. So he's got the VBO there. VAO, VBO. That's all good. EBO. Okay. Gen buffers, element array buffer. So that is right. Okay. Buffer and EBO. We just pass it like that. So we have an EBO now, and then we want to say bind buffer, element array buffer, EBO. Thanks, Pat and Zillow. Thanks for watching. Okay, and then we're going to buffer the data. We're going to say data.elements. What is the size? Size of data.element size bytes elements and GL dynamic draw. Okay. So when we generate the chunk, let's just add that data in there too. So we'll just have size t, vertex size bytes, element size bytes. Okay, and then we're going to go ahead and set those. So vertex size bytes should be however many vertices we have. So that's going to be like size of vertex times the number of vertices we have, which is just this. I should really change this into a constant variable because that makes this easier. Okay, then, and we have that times 8. Dot element size in bytes. Element, did I spell that wrong? Nope, that's it. Okay, size of int32 times all that times 36. Right? Yep, times 8 times 36. Cool. So now we've got all that stuff set up, and then this should be good. And we're going to have it changed up a little bit, right? Our vertex now is just a vec3 followed by vec2. So vec3 followed by vec2. Change that to 1. Change that to 1. This is just going to be, let's see, what is this? This is the stride. This is just going to be size of vertex. Change that to size of vertex. And then we can change this to offset of vertex. And I think this is like UV. I think that's how that works. We'll see if it works or not, and then change things if we have to. Okay, cool. So we've got all that. We upload the texture. That's good. Let's change up the shader real quickly. And I think that should be it. And then we can test this and hope it works, but I have a feeling it won't. Okay. So change that to 1. And we no longer have color going out. So let's just get rid of color. Get rid of that. We weren't using it anyways. Okay, cool. World.cpp. Let's see what happens, because I think that should be it. That was a lot of code to write without testing anything, but I guess there's not really much you can do. Okay, so we get an error here. What's going on? The variable EBO is being used without being initialized. Yeah. Oh. I forgot to do this. That would make sense. Okay. And then we bind it. Oh, I just did bind buffer twice. Okay, so I just messed up that call. Cool. Okay, let's try this one more time. Okay. We've got 2 triangles. And I'm like limited by my movement. I can't move a certain amount. Yes, never does work first try. Yeah, it's really weird. Like my movement is locked too. Huh. First of all, let's fix that real quickly and then I'll see if we can figure something out. Okay, position times speed, position minus speed. Is it my movement is locked, or is it just like a bunch of triangles like that I just keep seeing? No, I think it's my movement is broken. Oh man, okay. I really don't feel like debugging this right now, guys. So I think I might end off the stream here. I know it's kind of a bad place to end the stream since we're in the middle of a bug, but I'll probably fix this off camera. Unless you guys want me to wait till next week to fix this. Whoops. Just let me know. And then we'll pick this up next week with chunk creation, and maybe we'll actually start using Perlin noise instead of just generating flat chunks. So I hope you guys enjoy this. If you did, I would say please hit like and subscribe, but you can't do that. So I'll see you next week, guys. All right. Thank you for watching.